Hi, this is Jim Sutton of Stone Tablet Innovations. This is the second video blog in a series that's designed to help you learn how to make Internet of Things applications. Today we're going to look a little bit at the Espressif's ESP32 chip for Internet of Things devices. It's an excellent chip and we'll be using it in some of our projects, and you might want to consider it too. Espressif is from Shanghai, China. They're fabless, which means they do design work, but they outsource the actual manufacturing. They build low power systems on chips, and these include microcontrollers with integrated Wi-Fi and dual mode Bluetooth. This means that everything you need to do a IoT application essentially sits in one chip. Espressif uses the computers, the microcontrollers that are actually designed by Tensilica Extensa, and they're based in Silicon Valley, California. And the chips themselves are manufactured by the biggest company in Taiwan, Taiwan Semiconductor Manufacturing, using their 40 nanometer manufacturing process, which is obviously state of the art. It's cool because you get full function in a single chip. The chip we'll be working with has a dual core. It's a 32-bit LX6 microprocessor operating at 240 megahertz and performing at up to 600 DMIPS. That's dry whetstones or whatever. And that's based on a scale that put in a 1970s computer, the DEC-VAX 11780 at a DMIPS of 1. So if you see in the right, we have a photo of the DEC Digital Equipment Corporation VAX and the little 1-inch chip in right to the corner. And the little 1-inch chip is 600 times as powerful. Well, anyway, back to the chip. It has a good amount of RAM on the chip and supports Wi-Fi, Bluetooth, and low energy Bluetooth. It has some important built-in input and output interfaces. It has 12-bit analog to digital converters and up to 18 of these. And it has digital analog converters as well, 2 of them. And importantly, it has 10 general purpose IOs that could also be used as capacitive touch sensors. And they have a built-in ultra low power analog preamplifier if you have a small signal that you need to amplify. I won't go into each one of these details, but it has, it's supporting a lot of communications. This I2S is for used for audio applications. You have your standard UART, Ethernet, and you can hook up an SD host controller. Strong security features, supporting very good encryption on Wi-Fi, and it has great power management features. And this means this is an appropriate chip to use for a system that may only be battery powered. So full function, low power, and we'll get into later low cost. The chip actually that we'll be using actually rides on top of a development board, and this is showing a little picture of the development board with where the buttons are for boot and flash programming here. To get going with this, it's pretty simple and not too expensive. We have the development board that is available from 2 two different companies. That development board is only $10. The power programming cable I also got from Mouser. You have to watch a little bit because some of the cables that for USB micro only are for power, and we need all the data lines as well. And if you look in the notes below, I'll include the exact model number that I know works. The breadboard, it's nice to have a breadboard here that you can plug the chip into. I think an excellent one is the Global Specialties PB103. That you have to watch a little bit. The chip's a little bit wide, so it may not fit on every breadboard. And it's nice to have some blinker hardware, just an LED and some resistors. The Espressif provides quite a bit of software, including some APIs for network functions. So they have built-in stuff to let you talk to Azure, Amazon Web Service, or Apple Home. They handle a lot of the encryption schemes without too much work on your part. And they have a wide number of drivers and project templates. And we'll be going through some of these example projects in the blog series. So conclusions, this ESP32 is a great chip to do an IoT project with. It's excellent hardware at very low cost. The development board is only $10, and as you go into production and don't need the development board, the chip only is only $3.80. So it's easy to build a breadboard and get started building your own stuff. So I want to thank you, and please subscribe to this channel if you're interested. Bye-bye.